For 50 years, the best radios on Earth have listened to the stars and heard only the stillness of empty space. Statistically, that makes no sense. 100 billion planets like ours, many older than Earth, should be shouting their existence by now. Some scientists call that emptiness the great filter, the quiet residue of civilizations that never made it past their first mistakes. The term is new, but the question behind it isn't. It was born one evening at Los Alamos, when Enrico Fermi looked up from his lunch tray and asked, "Where is everybody?" But before we travel to that famous lab in New Mexico, if you find yourself genuinely pulled towards stories of mystery, conspiracy, and forgotten lore, please consider subscribing. And if you truly like tonight's story, a gentle press on the like button or a friendly comment sure does go a long way to keep these journeys coming. Now, let's get back to tonight's story. The air over Los Alamos still carries the faint trace of ozone that lingers after lightning. Dusk folds across the mesa as a handful of physicists linger in the cafeteria, their trays half cleared, talk drifting between atomic yields and weekend plans. Outside, the desert hums with the low resonance of heat leaving the sand. Then, with a fork poised mid-air, Enrico Fermi looks up from a quiet calculation and says the line that will echo through the decades. "Where is everybody?" The remark lands softly, more curiosity than challenge, but its weight clears the table. The others glance at each other, half amused, half uneasy. Because everyone there knows what the math predicts. If even a small fraction of stars host life, and if life spreads, then the night sky should be full of evidence. Instead, it is completely silent. That single question would later wear a title, the Fermi Paradox. A contradiction between what should be abundant and what we actually find. The paradox is simple enough to write on a napkin, which, some say, is exactly how Fermi framed it that day. If the universe holds hundreds of billions of stars and many are older than our sun, then intelligent life should have had time to appear countless times over. A species a million years ahead of us could cross the galaxy with technology barely imaginable. Yet our telescopes record no radiant cities, our receivers catch no deliberate signal, only the faint natural noise of stars breathing in radio bands. When Fermi first asked it, humanity hadn't yet reached space, but hope was already orbiting. After the war, optimism coated scientific ambition like a new alloy. Within a decade, rocketry promised moonshots, and astronomers began tuning dish antennas toward the stars. The search for extraterrestrial intelligence, SETI, took shape from that optimism, a way to turn nervous curiosity into data. The first major attempt, Project Ozma in 1960, pointed a telescope in West Virginia toward two nearby stars. The equipment was primitive by modern standards, but it carried a quiet faith that somewhere, someone was sending a greeting. The scopes hissed for weeks. Nothing arrived. Decades later, great instruments would bloom in the same desert Fermi once walked. The Arecibo Observatory in Puerto Rico, carved into limestone, listened to the sky through a bowl 500 meters across. Its receivers sifted through thousands of frequencies, adjusting for celestial drift and atmospheric clutter. Year after year, it sent back no signal that could not be explained away by satellites, pulsars, or human static. Yet silence began to feel like an answer in itself, its constancy heavier than noise. The night of August 15th, 1977, brought a brief flash of hope, a strong, inexplicable signal recorded at Ohio State's Big Ear Telescope. The astronomer on duty circled the burst on a printout and scribbled a single word beside it: "Wow." For weeks the team searched for another trace, the voice never repeated. Some researchers compare that ongoing stillness to a kind of cosmic control sample. If it were only a matter of bad luck, patterns would have appeared by now, weak signals doubling back, random blips forming clusters. Instead, across every wavelength, all we meet is quiet. SETI's expanding network of antennas has surveyed millions of star systems, from local dwarfs to distant spirals. Nothing yet reveals industrial signatures, orbital megastructures, or wandering probes. The odds mock our tools. The more powerful our receivers become, the emptier the channel grows. Faced with contradiction, scientists did what they always do: write an equation. Frank Drake's formula from 1961 was not meant to solve the paradox, only to map its boundaries. The Drake equation multiplies 7 uncertain factors, from the rate of star formation to the lifespan of detectable civilizations. At first, it seemed a framework for optimism. Plug in even cautious numbers, and the galaxy should host thousands of intelligent cultures. But as data improved, the discovery of countless exoplanets, the steady cataloguing of habitable zones, the silence grew more absurd. Every new piece of evidence that life could be common tightened the mystery of why we see none of it. Scientists and dreamers alike have tried to narrow the possibilities. Maybe we're listening wrong. Maybe other species use mediums we haven't considered. Quantum entanglement, neutrino bursts, or gravitational waves. Yet years of adjustment, fresh instruments, and expanded frequencies keep yielding the same outcome. Arecibo has shut down. Its dish collapsed, but its legacy endures as an unintentional monument to unanswered listening. The Fermi Paradox eventually stopped feeling like a riddle about aliens and began to look more like one about survival. If intelligence blooms easily but rarely lasts, the silence might be a map of extinctions. Each blank coordinate in the sky could mark where one species rose, reached for the stars, and then fell quiet forever. CT veterans sometimes speak of the quiet not as emptiness, but as a kind of memorial, an absence filled with implication. That line of thought bends towards something darker, a theory raised decades later by economist Robin Hanson, who wasn't an astronomer at all but saw in the data a pattern of attrition. He called it the Great Filter, a term as sterile as it is haunting. Somewhere between the spark of life and the mastery of the stars lies an event or threshold that nearly no species survives. Hanson's logic came directly from the paradox. If countless worlds had lifetimes to develop intelligence, yet none appear, something must eliminate most before they can be noticed. To understand how unnerving that is, you need only consider how long Earth itself stayed simple. For billions of years, life here meant bacteria clinging to rock. The jump to complex cells, to multicellular creatures, to minds, all were improbable leaps through narrow doors. It may be that one of those doors closes almost every time. The quiet might not be disinterest at all, but aftermath. The paradox reveals its subtler cruelty when we recall how eagerly humans sought validation beyond Earth. The space age promised companionship, other minds, other voices. Children who grew up watching moon landings and early shuttle launches expected contact soon after. Instead, the radio sky stayed still. The vast catalogues of exoplanets discovered later, Kepler's thousands, Tess's hundreds more, expanded the sense of possibility without breaking the quiet. Each new discovery deepened the contradiction. The numbers shout abundance, but the universe answers in whispers. For SETI engineers, the search has become both scientific and existential. Generations have cycled through the observatories. New faces repeat the same rituals. Headsets pressed against static, screens flickering with faint signals. At Arecibo's control room in its final days, an operator could be found alone before dawn, marking columns of spectral lines in blue pencil. She worked methodically, knowing the odds, but also knowing that silence itself accumulates meaning. The way a painter's empty space defines the subject. Every unbroken line of static says something about how rare endurance may be. Through the decades, hope has mutated into patience. Projects once driven by expectation now proceed with quiet devotion, scanning because silence itself is still a form of data. Researchers treat the cosmic stillness the way geologists treat fossils, evidence of processes too vast to witness directly. Perhaps the same conditions that nurture life also guarantee its eventual fragility. Perhaps every civilization approaches a level of complexity that becomes its own undoing. Or perhaps the filter sits behind us, and we are late survivors of an unseen culling. Still, there is beauty in not knowing. Some thinkers describe the Fermi Paradox as a mirror, reflecting our assumptions about progress. It forces us to ask whether intelligence naturally seeks expansion, or if restraint might be the truer test of maturity. Other species, if they ever existed, could have chosen secrecy or self-containment over broadcast. The stillness may be deliberate camouflage, the galaxy's quiet pact. When you look at it that way, silence stops feeling empty and starts feeling strategic. Yet underneath all speculation lies the simple emotional truth of that cafeteria moment in 1950. Fermi's question was not meant to frighten. It was the sort of curiosity that surfaces when data and wonder collide. 70 years later, the question hasn't aged. We now orbit telescopes around Earth, map exoplanet atmospheres, even detect potential chemical traces of biology light years away. And still, no reply. What began as a lunchtime musing has expanded into one of science's most persistent puzzles, shrugging off each attempt at resolution. The paradox endures because it is uncomfortably balanced between probability and evidence, between what logic promises and what the universe allows us to witness. That gap between certainty and reality may hold the true message. Perhaps others did exist and fell to their own thresholds long ago. Perhaps the void is not indifferent, but selective. Each star around us could mark a past attempt, a civilization that reached for the same transmitter knobs, the same hopeful frequency, before drifting into quiet. When the data offers nothing but background noise, even silence becomes a clue. Some whisper that the quiet sky may be self-maintaining, a built-in purge coded into cosmic time. Others see compassion in it, a buffer protecting worlds from one another's mistakes. Either way, we continue to listen, and that listening has slowly changed its purpose, no longer a search for alien greetings, but an examination of what it means to last long enough to be heard at all. The Fermi Paradox at its core may not ask where is everybody anymore, but why are we still here? And if that's the real question, then somewhere between life and the stars there must be gates, unseen trials waiting in the dark, each one testing whether any intelligence can cross and remain. It began, oddly enough, with an economist, not an astronomer or a physicist scanning faint radio bands, but Robin Hanson, a man trained to follow incentives, to trace where value and failure collide. In 1996, he proposed a simple but unsettling thought experiment. If intelligent life should be common, why is the sky still so still? His reasoning didn't reach for alien conspiracies or secret signals. It turned inward, toward probability. Somewhere between the birth of a habitable planet and the rise of interstellar civilization, he said, there must be a bottleneck so narrow that almost nothing passes through. The Great Filter, he called it, a term that feels less like a theory and more like a quiet warning. Hansen looked at the chain of steps any species must climb to reach the stars, a long staircase built from chemistry, biology, and luck. A planet must first form around a stable star with the right elements to build life. Then molecules must self-replicate. Cells must evolve, split, merge, become complex. Intelligence must arise, and with it, the ability to shape tools, language, and curiosity about the wider void. But almost every one of those steps could be the fatal one. If even a single rung is nearly impossible to climb, that would explain the cosmic stillness as neatly as any conspiracy. The silence isn't mysterious at all, it's statistical. When you think of it as a staircase, the metaphor grows darker with every step. The first rungs gleam faintly. Organic molecules, replicating chains, microbial mats thriving in shallow seas. but higher up the metal turns slick. The gap between simple and complex life stretches across 2 billion years. One slip on that rise, and the story ends in the mud. And above those early steps, the light begins to fade completely until the top vanishes into unseen night. No one knows how many steps remain. No one knows what waits at the final landing. There's an odd beauty in the quiet logic. If the galaxy is really that silent, it may not be by accident, but by attrition. The Great Filter, in Hansen's framing, is less a wall than a series of narrowing gates. Each one allows only a few travellers through, and those who fail disappear without trace. It's not cruelty. It's just how the odds fall when billions of worlds attempt the same climb. To listen for alien civilizations, then, is also to take attendance at a cosmic funeral that never ends. For humans, that image cuts close. Our species is already partway up the staircase, looking back at the dark water below. Life on Earth has survived ice ages, meteor impacts, and runaway oxygen crises. It created cells so complex their ancestry traces to a single act of symbiosis, a cell consuming another and refusing to digest it. That might have been the first gate, and we passed through it by sheer accident. The filter didn't break us. It bent in our favour for once. But no one can say how many gates come after. Early Earth was an unlikely survivor. Roughly 4 billion years ago, its surface boiled with volcanic steam and ultraviolet radiation. Microbes clung to vents and shallow edges, reproducing in slow chemical rhythm. For 2 billion years, they stayed that way. Tiny, patient, unaware they had already done something extraordinary. If this step were the filter, then life itself would be vanishingly rare, and humanity, by existing at all, would already be one of the universe's luckiest accidents. Every starless valley, every dry exoplanet we find might just be another world stuck before that first gate ever opened. Yet if life itself is common, the filter must lie ahead. That thought carries a special strain of dread, because then the danger isn't the long dead past, it's the still forming future. Maybe most civilizations reach the level we've achieved, radio signals, satellites, nuclear power, and then encounter the true barrier, themselves. The silence in the data could be the echo of countless species that burned too brightly, too quickly, before they could spread beyond their cradle. Still, there's a slender line of hope running through the theory. If the hardest trials are behind us, if complex life or intelligence were the true bottlenecks, then every dark world we've yet to decrypt becomes good news. Each empty sky could mean we're one of the few to pass through, a rare survivor, a fragment of improbable success drifting through a cemetery of stalled beginnings. On nights when new exoplanet discoveries make headlines, that thought has a strange comfort to it. The absence of evidence for once feels like evidence of triumph. But sometimes the hope reverses. Supporters of the theory warn that the most terrifying discovery humanity could make might not be a signal, but simple microbial life on another planet. Because that would mean those early hurdles, life forming, cell surviving, are easy. Not filters at all. If microscopic life is common out there, yet no civilizations ever emerge, then the barrier must sit at or beyond our current step. Somewhere near now, in the stretch of time we still call the future. The Great Filter wouldn't be behind us but waiting on the next landing. You can almost sense that tension in the air whenever scientists discuss new biosignatures or chemical traces from distant worlds. The voices stay measured, but behind the data there's a quiet fear. What happens if the evidence confirms that life starts easily but never lasts? Each confirmation shrinks the odds that intelligent life survives long enough to be heard. The silence becomes a countdown. Some whisper that the stillness of the Milky Way isn't just the sound of absence, it's the record of failure, an archive without witnesses. If hundreds of billions of planets rolled the same dice and lost, then we may be the only example of life that slipped through the narrowest statistical crack. Others dismiss that conclusion as fatalistic. They argue the quiet may reflect only our limited tools, not cosmic extinction. But even skeptics admit Hansen's framing changes how we think about time. Progress, once a measure of triumph, becomes a measure of risk. To give the idea weight, picture Earth's history as a climb already millions of steps high. The moment cells learned to share energy through organelles was one step. The rise of multicellular organisms another. Intelligence, language, fire, tools, stories, perched halfway up. Industrial technology only appeared a heartbeat ago in evolutionary terms. If we assume each stage is a gate that blocks most species, then we are already improbably far along. But probability doesn't promise survival. It only measures how thin the air becomes near the top. Scientists at places like the SETI Institute and Oxford's Future of Humanity Institute tend to treat the filter not as philosophy, but as math. If Earth hosts life and intelligence, then something must explain the lack of equivalence elsewhere. Either early steps are almost impossible, or advanced civilizations self-destruct. Both answers make the same demand: humility. One tells us we're rare, the other warns we're doomed. It's a narrow emotional space between awe and anxiety. Our telescopes search for neighbours, yet every new silence returned also affirms the theory. Some listeners have grown superstitious about it, the idea that by peering too deeply we're tempting statistics to claim us. But the science remains sober. The great filter doesn't predict doom, it describes odds. What we do with that awareness, however, turns it into something moral. How do you live knowing your species might be walking the same path that ended for countless others? When the concept first entered popular discussion, it rattled more than just scientists. Even philosophers and policymakers began to weigh its implications. A civilization that understands filters might try to outthink them, diversify its habitats, minimize self-inflicted catastrophes, treat every decision as potential leverage against extinction. In that sense, Hansen's economic background fits perfectly. He wasn't chasing mystery, but efficiency. The cost of failure is everything, the reward survivorship itself. Still, theory only comforts so far. Imagine, one early morning, a researcher compiling data from a new exoplanet survey. There's excitement in the numbers, spectral hints of oxygen, traces of methane balance, but no signature of intelligence, not one. The trembling she feels isn't disappointment but recognition. The data isn't empty, it's precise confirmation of the filter's shape taking form. Somewhere, another biosphere might have tried and failed just as we could. She marks the results in quiet handwriting, aware that she's recording another ghost step in the climb. From a cosmic distance, the great filter reduces civilizations to short-lived flares along a vast timeline. Each burns briefly, perhaps sending a few fragile signals outward, then cools into static. Our instruments sweep through those ancient afterrings, finding nothing but background hiss. Yet within that emptiness lies the pattern Hansen offered. The odds arranged in a tidy line, the staircase rising into dark uncertainty. Not chaos, not punishment, just the structure of difficulty itself. The theory also unites two very human desires, to know and to endure. If the universe filters almost all life before it spreads, then survival itself becomes a form of discovery. It tells future astronomers that intelligence can pass the test, that awareness isn't automatically self-extinguishing. In this way, every new telescope launch, every mission beyond Earth's gravity, doubles as both experiment and prayer. We are testing whether wisdom can outlast entropy. For now, the filter remains an abstraction, a map drawn in probability, not experience. Somewhere between the molecular and the technological, the barrier waits, invisible but certain. Some think it's already behind us, a chapter closed the moment our ancestors built the first complex cells. Others think it's ahead, disguised as our own ingenuity, our fragile ecosystems, our insistence on playing with forces we barely grasp. Whichever direction it lies, the logic is the same. This silence isn't empty space. It's the sound of everything that didn't make it. And still, the climb continues. Each new probe, each line of code, each debate about survival underlines the same mystery. If we are on the staircase, how many steps remain before the lights go out, or before we break through into the impossible glow of interstellar dawn? The only way to know is to keep climbing toward the next gate, the next fragile chance that something waits beyond the dark. Out there, if the Great Filter is real, it may not be a single event, but a staircase. 9 fragile rungs from nothing to everything. The bottom is bare rock and chemistry. The top is a civilization capable of colonizing the stars. Between them, each rung waits in the dark, slick with improbability. Move too quickly, and a species slips. Hesitate too long, and the light goes out. The strange truth is that almost every planet likely dies on some forgotten step, leaving only silence where success should echo. When Robin Hanson listed those 9 steps, he wasn't drawing prophecy, he was tracing retrospect. The path begins with the simplest self-replicating molecules forming from chaos. Then, the first true living cells emerge, fragile systems sealed from their hostile surroundings. The third step is the leap from these simple cells to ones with internal engines and organelles, complex blueprints capable of endless variation. Only afterward can multicellular life arise, networks of cells cooperating rather than competing. Then comes animals with complex nervous systems, and, much later, intelligent tool users who sculpt their environment. The 8th step sees technology, satellites, signals, and civilization aware enough to call out across the cosmos. The 9th would be expansion beyond the cradle, mastery of multiple worlds. On paper, it's a short list. In time, it spans eternity. Each rung demands near-perfect harmony of chance and condition. The right mix of elements, the right climate cycle, the right spark of mutation, and it must persist long enough for nature to test it again and again. Earth required more than 4 billion years to reach step 8, and even then we stand trembling on it. For most planets, the odds may look like cruel arithmetic. One missed connection, one unstable chemical chain, and evolution simply halts. There is no restart button for biology. Once a world fails, it waits forever under silent stars. Take step 4, where the improbable becomes microscopic drama. Around 2 billion years ago, life on Earth hit a wall. Simple cells could divide, photosynthesize, even adapt, but none could grow much more complicated. Then came a merger that shouldn't have worked. A free-living bacterium invaded another cell, not as a parasite, but as a companion. Instead of digestion, they found arrangement. The invader became mitochondria, the tiny engine still humming inside our cells today. That union gave rise to eukaryotes, the scaffolding for all higher life. It happened once that we know of, only once in the entire fossil record. If not for that moment of unlikely coexistence, Earth would likely still be a planet of bacteria and algae, its oceans busy but forever mindless. Biologists who study this ancient partnership speak of it with quiet awe. Under microscopes, human cells show the faint inheritance of 2 separate genomes that learn to share their fate. A symbiosis in which both partners surrendered something, and, in doing so, created the means for everything complex that followed. Plants, coral reefs, forests, mines. The chance that 2 single-celled organisms would meet in that exact way, tolerate each other, and produce a stable lineage might be vanishingly small. A cosmic accident mistaken for evolution's inevitability. That's the cruel arithmetic Hansen warned about. On a million moist, temperate worlds, there may be life that stopped right there, trapped before complexity. Oceans filled with unthinking activity, bacterial mats crawling across stone, none with organs or eyes to look upward. The Great Filter could be nothing more than inertia, a universe snared in its own simplicity. If so, the silence between stars is not warning, but proof of abundance gone nowhere. And yet, when complexity did take hold, it crawled slowly. Multicellular organisms appeared only after another long epoch of dormancy. Then came eyes, fins, limbs, lungs, the improvisations of deep time. Still, intelligence hesitated. For hundreds of millions of years, ecosystems grew intricate yet stayed instinctive. Nature seemed content with stability. Intelligence, with all its cost, comes rarely. Big brains require enormous energy and precarious balance. Predators could live without imagination. Plants photosynthesized without memory. The machinery of evolution was never designed to produce philosophers. When the first stone tools appeared in the hands of early humans, they were more than artifacts. They marked the 7th rung on Hansen's ladder, the spark that separates adaptation from intention. It may have taken countless failed experiments in cognition across deep time for one lineage to reach that novelty. We like to think minds arise because they are useful, but perhaps they appear only through improbable cascades, the right brain shape, social structure, and environment aligning in one delicate conjunction. Intelligence may not be the rule, it may be the anomaly. From another angle, the ladder seems cruelly inconsistent. Some steps appear easy, like the formation of simple microbes. Others, nearly impossible. Earth's timeline proves this without speech. The first cells appeared early, within the planet's first 500 million years, yet for the next 2 billion, nothing much diversified. Only after that great waiting did animal life erupt in brief geological flashes. The Cambrian explosion, diversification, extinction, renewal. It is as if nature hoards complexity and releases it in bursts. Perhaps those pauses are filters too, delays built into the design of life, weeding out instability before it can scale. When archaeologists unearth vanished human settlements, cities swallowed by dust, empires undone by drought, they sometimes speak as if they're reading planetary parables. Civilizations can disappear without war or cataclysm, undone by the slow grind of unsustainable complexity. On a cosmic level, the same pattern may play out endlessly. Planets abundant with potential may rise through the early rungs, then stall not from violence but stagnation. Their achievements never reach the stars, their signals never leave the atmosphere. The failure isn't always dramatic. Sometimes it is quiet suffocation under the weight of improbability. If we picture those planetary histories as overlapping timelines, we might see billions of faint starts, microbial flickers that never grow bright, complex ecosystems that lapse before birthing intelligence. The silence of the galaxy may be dense with those failed beginnings. Not graves, exactly, but paused experiments awaiting no outcome. Each one a small note of absence, folded into the cosmic background. Humanity's own climb reads like a miracle in comparison. From chemical soup to culture, we have already passed through 8 near-impossible gates. Yet survival at each stage depended on accidents both microscopic and monumental. One asteroid missing its mark, one climate swing delayed, and perhaps step 8 would have belonged to another species, or none. Our current existence might therefore represent not triumph, but improbability so vast it teeters on absurdity. Supporters of Hansen's view sometimes describe these steps as nature's quality control, the system's way of ensuring that only the rarest, most stable configurations reach awareness. Others dismiss that idea as anthropocentric fantasy, suggesting there's no intention behind the filtering at all, only statistics. Either way, the result's the same. Almost everything fails long before it can build rockets or write theories about failure. The ladder, then, is not a promise. It's a sieve that looks like progress. Each success narrows the path further, demanding complexity beyond proportion. Even the jump from multicellular organisms to self-aware beings may be narrower than we dare admit. And if the next step, interstellar survival, requires solving global cooperation, tempering technological risk, or outpacing environmental collapse, we could already be approaching the last thin rung. Consider what the fossil record shows when viewed as a clock. Life spent more than half its history invisible to the naked eye. Multicellular forms filled one small segment, while intelligence occupies a line so thin it barely registers. If sentience were a candle's flicker, planets alive for billions of years might never hold it long enough for the flame to stabilize. Some whisper that advanced beings may briefly achieve awareness, glimpse the cosmic ladder, then vanish from self-made catastrophe or cosmic chance. The dark between stars could be filled not with waiting civilizations, but the ghosts of almost successes. Earth's own silence about its deep past hints at the fragility of progress. Geological layers erase civilizations perfectly well. Given time, even metal decays, data burns away in the crust. If another species reached technology millions of years before us, we might never know. Planetary memory is short. That realization brings humility, the possibility that intelligence could rise more than once and still vanish without trace. So Hansen's 9 steps are less a map than a memoir written by chance itself. Chemistry to life, simplicity to complexity, mind to civilization, each one an audition for endurance. We don't know how many failed scripts litter the galaxy, but the stage directions seem consistent. A brief line of progress, a long silence, then lights out. Perhaps that's why our species builds telescopes and radio arrays, to check if anyone else survived the test. But the deeper lesson is inward. Knowing that life's climb is steep doesn't guarantee we stand near its summit. If the true filter lies ahead, progress may carry its own price. Each new discovery increases both our reach and our fragility, tightening the paradox. The higher we climb, the thinner the air becomes. If the first 7 steps shaped biology, the 8th belongs to technology, and its burden feels heavier than evolution's patience. The difference between a species that stops here and one that endures lies in restraint as much as invention. In Hansen's framing, this is where the gauntlet shifts from chance to choice. Our decisions, environmental, political, ethical, will decide whether humanity becomes another stalled story or the rare continuation. Somewhere above us, the 9th rung waits, the point at which civilization spreads among the stars, free of single-planet doom. But reaching it may require surviving our own inventions, balancing the energies we've unleashed without slipping. Step 9 may not be about distance at all, it may be about duration, to last long enough to climb, to hold the light in an unwelcoming dark, and if humanity truly stands at step 8, that trial has already begun. 4 billion years ago, long before continents formed or oxygen brightened the air, the oceans held only drifting cells. They collided, clung, and divided in cycles too small for memory. Among them, one encounter ran differently. A primitive cell drew another inside, not to digest it, but to keep it. That second cell continued to breathe, burning chemical energy with a speed the host had never known. Together they survived, and in that unlikely alliance, the pattern of all future complexity began. Life's first partnership was born quietly, in water the colour of iron. The story leaves no fossils, only clues in the sequences of modern genes. Inside every human cell lie mitochondria, tiny descendants of that ancient guest, still containing fragments of their old bacterial DNA. Biologists comparing genomes can trace this inheritance back to a single ancestor species, one that lived billions of years ago. It means the merger happened once, and only once, in all of Earth's history. Every tree, insect, and person is an echo of that moment. If it had failed, the engulfed cell digested, or the host poisoned, the planet might still belong solely to the microbes. No forests, no mines, no art. Only endless microscopic hunger. Endosymbiosis, one cell living inside another, sounds mundane at first. But for billions of years before it, nothing of that scale had succeeded. Cells competed, consumed, or ignored each other. Fusion required precision, luck, and timing so exact it seems less like strategy than accident. The host had to absorb but not destroy. The guest had to outlast the shock and find coexistence. Somehow, that improbable dance stabilized. The inner cell became the mitochondrion, a miniature generator transforming oxygen and nutrients into power. That transaction unlocked the energy budget life needed for experiments in shape and structure. From that point, complexity could bloom. Larger cells used their energy reserves to build compartments, chromosomes, and internal scaffolds. They grew membranes that folded inward and outward, making possible limbs, leaves, and eyes. Compared to the stillness that came before, it was like morning after eternal dusk. Yet the transition was slow. It took almost 2 billion years from that merger to reach multicellular organisms. Against the Earth's whole lifespan, it was as if the planet held its breath, waiting through endless microbial ages for one improbable event. Geneticists who study mitochondria treat them as living fossils. Each carries its own small loop of DNA, a holdover from its independent past. When sequencing these loops, researchers can see how little their form has changed. Just enough to keep cells alive, not enough to blur the evidence of origin. One researcher once said tracing those genes is like following ancient ink across palimpsests of time. The message remains, faint but unbroken. Through that faint script, we know cooperation began not in altruism, but survival. Shared metabolism turned mutual dependence into permanence. For every planet where microbial chemistry stirs, supporters suggest similar alliances might hover perpetually out of reach. The right conditions must align, not just the physical meeting of two species, but environmental pressures favouring fusion over consumption. Too much oxygen, and both die. Too little, and energy scarcity prevents complexity. Earth's oceans, rich yet volatile, made the window wide enough for one success. Some whisper it's the rarest event in biology, a one-in-universe accident hiding beneath microscopes. Think of the lesson implied. Progress in evolution often begins not from conquest, but from surrender. One cell opened itself and found survival in coexistence. Every heartbeat today depends on that long-ago truce. The mitochondria inside you are still technically invaders, their DNA separate, yet their loyalty absolute. Cooperation became the engine of endurance. The universe may favour patience and partnership over violence more than we imagine. When researchers simulate the early Earth environment, they often describe it as minimal: metal-rich water, fluctuating heat, no oxygen shield. In those unstable shallows, cells endured real hardship. That hardship may have made flexibility valuable. Integration offered stability where competition didn't. The first partnership might have begun as a temporary shelter from stress. Over time, boundaries softened. The internal guest provided energy even as the host provided protection. What started as crisis adaptation matured into permanent symmetry. Now stretch that to a cosmic scale. On distant exoplanets covered in methane lakes or ammonia clouds, microbial life could struggle for eons, repeating early Earth's quiet experiments. Billions of tiny protocells meeting, engulfing, dissolving, nearly all failures. Perhaps a few reach equilibrium, but not the right one. Climate or chemistry interrupts before the partnership can persist. A planet might be alive yet frozen at the microbial step. A world humming with bacteria but never evolving a nerve, an eye, or a thought. The rarity of advanced life might not be because life seldom begins, but because cooperation seldom endures. The endurance of mitochondria across all complex organisms shows how complete the fusion became. Over generations, the host gene pool shifted, moving many essential genes to the nucleus, leaving the mitochondria dependent. The guest lost autonomy, but gained persistence. It could no longer live alone. This irreversible integration is what made the new cellular architecture possible. Cells suddenly wielded control over internal chemistry like a city managing its own power grid, directing which parts received energy and when. From that came shape, tissue, and eventually movement. If you stand now in a laboratory and watch biologists study cell cultures under fluorescent light, you can feel a sense of scale collapse. Each glowing dot in their slides houses thousands of mitochondria, each a relic of that ancient oceanic merger. The researchers adjust microscopes, write notes, and track patterns. They are descendants reading the diary of the event that made their minds possible. It's humbling work tracing the proof that complexity doesn't erupt. It accumulates through improbable unions. Some critics counter the assumption of uniqueness. They argue that given enough time and enough stable worlds, such mergers might occur more than once. Yet no second example has ever been found. On Earth's own timeline, even among trillions of bacterial interactions each day for billions of years, it happened only that single time. The odds remain staggering, and the absence of repetition deepens the mystery. If competition rules evolution, then cooperation at this scale breaks that rule. And if the rule breaks so rarely, the silence beyond Earth begins to make sense. Others dismiss the awe and frame it as inevitable, that the pressures of natural selection lead to complexity, given enough energy sources and geological stability. Still, the simplicity of microbial life may be the stable default. Bacteria thrive without change, outliving mass extinctions and planetary chaos. From an evolutionary standpoint, stability is success. Complexity is a dangerous gamble, requiring enormous sustained energy. Perhaps simplicity wins almost everywhere else. Let the frame widen again. A galaxy might hold countless planets caught in this early biological plateau, alive yet muted, seas breathing carbon and sulfur but never reaching cognition. Perhaps intelligence isn't the standard outcome of life, but its distant anomaly. We look up at the stars asking who else might think, while most worlds never learn to think at all. If the great filter hides here, it takes the form of an absent merger, the step from single to double life. Back on Earth, once that step was crossed, the possibilities expanded faster than geology could record them. Within a few 100 million years, multicellular organisms diversified into corals, plants, mollusks, and vertebrates. Every evolutionary branch owed its momentum to the same mitochondria-derived energy. A single ancestral event unlocked the chemistry for every heartbeat and synapse thereafter. It was not an explosion, but a slow ripple, moving outward across time until one strand shaped itself into us. The Union also left a philosophical fingerprint. We usually define advancement as dominance, stronger over weaker, predator over prey. But the origin of higher life came from partnership, not power. Cooperation proved more durable than predation. In the cosmic sense, that's a quiet warning. If survival across eons demands harmony even at the cellular level, what might that imply for civilization's choices now? The same rule might scale upward. Endurance favours balance, not conquest. Some whisper that civilizations echo their biology. A species born from union may only endure if it learns the same lesson. Energy shared carefully, diversity sustained rather than consumed. The mitochondria remain, multiplying unseen in every cell, as if reminding us that the cost of losing cooperation is regression to silence. On other planets, perhaps the absence of such unity keeps life soft and microscopic, eternally simple. As the microscope light fades, the pattern still glows in afterimage, a living testament that complexity itself is fragile, conditional, and perhaps unique. One alliance in one ocean long ago set the stage for thought, art, and science. Without that single merge, the cosmos might shine just as brightly, but with no eyes to see it. The next step, the leap from thought to enduring wisdom, waits ahead like another filter unseen. Evolution's miracle may be civilization's rarest inheritance. Across nearly 4 billion years of life reshaping itself, consciousness appears only once that we can trace, a single flare of awareness in a long night of instinct. Earth has birthed trilobites, ferns, lizards, dragonflies the size of hawks, and yet only one branch seems to have stepped beyond survival to ask why it exists at all. That fact sits quietly, heavier than it sounds. For all the billions of species that have come and gone, thought, sustained, reflective, creative thought, arose here exactly once. The fossil record reads like a script of endless experiments, most of them abandoned. For ages, brains expanded or shrank, depending on what the environment asked for. Some marine creatures grew intricate eyes but never language. Dinosaurs, masters of adaptation, ruled for 150 million years without writing a single symbol in the mud. Intelligence as we define it, tool use, abstraction, shared memory, was not a prerequisite for success. Even the grand designs of evolution seem to avoid it when simpler solutions work just as well. Perhaps nature considered it wasteful. When early hominins began shaping stones in the African heat, the gesture was tiny, almost irrelevant. A chipped edge here, a smoother grip there. Yet each blow of rock against rock pressed a thin mark into time. Homo erectus knelt in the dust, both hands steady, unaware that this routine might be another planetary test, one rung higher on the same invisible ladder. Firelight flickered over the newly shaped tool, scatters of ochre dust catching on the skin. Around them, no one could predict that this coordination of mind and hand would alter the fate of an entire species. The sky at night was already thick with stars. None offered a hint that such deliberate thought was unusual. Across continents, ecosystems stayed stable for incomprehensible spans of time. Coral basins pulsed, shallow seas receded, forests replaced one another. Through it all, life multiplied but rarely innovated. Change came through structure and colour, not intellect. Even when mammals began navigating complex societies, wolves, dolphins, elephants exchanging calls and gestures, none advanced toward the strange loop of self-awareness that let humans ask questions about the universe. If the Earth's timeline were a 24-hour day, intelligent consciousness occupied the last few seconds before midnight. That brevity might explain why we still fumble with our own curiosity like children holding matches. Intelligence takes energy, a lot of it. The human brain burns roughly a fifth of the body's fuel, an extravagant expense in evolutionary terms. For most creatures, conserving resources means survival, so investing in abstract thinking is less strategy and more gamble. That gamble nearly didn't pay off even for us. The fossil trail shows bottlenecks where our ancestors dwindled to a few thousand individuals, small tribes that could have blinked out with a disease, drought, or eruption. The late Pleistocene was heavy with risk, yet those small bands persisted, building memory networks through language. Each story traded at a campfire widened their shared imagination and marked another step on that shadowed staircase towards something aware. Supporters of evolutionary contingency suggest that minds like ours are the rarest form of luck. If the so-called tape of life were to be rewound and played again, the same outcome might never appear. Perhaps reptiles or cephalopods could have reached cognition under different skies, but they did not here. The accidents that led to us, a cooling climate, a convenient mutation, a line of apes forced to stand and adapt, may never coincide the same way twice. It frames intelligence as an anomaly, a detour in evolution's rhythm rather than its goal. Under that lens, the cosmos grows even quieter. If vast worlds teem with organisms that never evolved minds capable of wondering about the stars, then the absence of alien contact stops being a mystery. It becomes a statistical certainty. Life might thrive beneath methane skies or beneath ice crusts, but it may remain content with simple cycles of division and hunger, forever blind to the void above. What looks to us like a tragedy, a universe without company, might simply be the default state of matter that lives but never thinks. Yet even on our planet, hints of potential flicker in unexpected corners. Crows drop nuts on roads for cars to crack, octopuses solve mazes and build shelters, dolphins invent games. These behaviours shimmer at the edge of what we call intelligence. Glimpses, not revolutions. They show how evolution toys with cognition, then turns away before crossing the threshold. Some researchers call this line the point of energetic bankruptcy. Beyond a certain complexity, brains become too costly to maintain without cultural feedback. Humans stumbled across that feedback loop. Tool use reinforcing language, language feeding cooperation, cooperation rewarding thought, and never stopped spinning it. Inside that loop, the mind became recursive, a mirror reflecting its own curiosity. Art emerged, then ritual, then myth. Each form fed a social instinct that outpaced biology. Intelligence, once a mere adaptation, unfolded into consciousness, dragging with it fear of death and a longing for connection. These emotions, while painful, serve a purpose. They keep a species reaching outward, inventing reasons to communicate. In cosmic terms, that yearning is both beacon and liability. The same drive that makes us broadcast greetings into deep space also accelerates the technologies capable of ending us. Critics counter that intelligence is not miraculous but inevitable given enough time. They see it as a convergent trait, like wings or eyes, re-emerging whenever conditions stabilise. But evidence offers little comfort. Over hundreds of millions of years, nature repeatedly refined vision, flight and photosynthesis, yet only one lineage built radio towers. If convergence applies universally, its tempo is glacial. The next spark of self-aware thought elsewhere may ignite only once in every trillion planetary histories. So far, only Earth carries the pattern of both predator and philosopher intertwined. The path is narrow. Too much aggression, and intelligence devours itself. Too little, and it never climbs beyond instinct. Balance seems to have come by accident. Perhaps that's why intelligence arrived late, as if the planet had to cycle through countless stable combinations before stumbling on a recipe volatile enough to produce imagination. Under such logic, minds are fragile phenomena, like frost patterns forming just before sunrise, magnificent yet temporary. Economic and ecological pressures shaped us as much as neurons did. Scarcity forced cooperation, disaster sharpened foresight. The great droughts of Africa may have pruned humanity down to the inventive survivors capable of planning migrations. Every crisis encoded another layer of awareness. The value of intelligence was not in power, but adaptability, solving immediate problems fast enough to survive the next catastrophe. But as environments stabilized, that same restless cognition sought new puzzles and new frontiers, from cave walls to orbit. The climb never stopped. Some whisper that intelligence itself may be nature's rebellion, matter briefly escaping its own blind chemistry to question the rules. If so, then we're anomalies in a cosmos content with simplicity. The hush between stars could represent not extinction but avoidance, existence rarely reaching the danger of reflection. From this angle, life that never dreams might outlast life that does. The silence becomes protective, not punitive, mercy, not emptiness. Still, awareness carries its own magnetism. Once it arises, it seeks its likeness in others. Our telescopes and probes repeat the same ancient behaviour that once made apes drumsticks against hollow logs, a sound sent outward just to be answered. So far, nothing has called back. But the act itself may be the essence of intelligence, to question into the void even without a reply. That drive suggests we are still climbing, still uncertain how far the steps continue. Over the next threshold lies civilization, a structure dense with inventiveness and danger. Once tools evolve into systems, the test shifts from imagining to managing. Fire becomes reactor, word becomes network, dream becomes algorithm. Each leap brings power but thins the margin for error. Evolution tested creativity for billions of years. The next test concerns restraint. Intelligence alone won't decide if we survive our own cleverness. Discipline might. Somewhere, on another world, perhaps a species almost reached this point. Minds bright enough to reason, bodies fragile enough to fail, a silence following their absence. If our silence follows afterward, then thought itself may be the universe's rarest experiment, destined to flare only briefly before vanishing. For now, we are its current form, still alive, still wondering. And as the night sky turns, the quiet question lingers. What happens when the act of thinking becomes the final threshold we're asked to cross? Firelight on stone walls becomes the glow of satellite panels slicing silently above the atmosphere. For a few heartbeats, both belong to the same lineage, a chain of brilliance stretching from one controlled spark to another. From that first campfire's crackle to the synthetic pulse of data orbiting Earth, the species that once warmed its hands now heats half a planet with its inventions. This is step 8. Intelligence discovering it can remake the world faster than it can understand its own reach. For the first time, the dawn no longer depends on sunlight alone. At first, that ability felt limitless. Wires carried thought. Circuits recalled memory. The same curiosity that shaped obsidian into blades shaped silicon into logic. But every new mastery drew a shadow behind it. The fire that powered factories also laced the air with invisible heat. Rivers dammed for electricity slowed to a trickle downstream. Forests thinned to feed progress that promised permanence. Humanity had built detectors to listen for other minds, yet it could barely hear its own warnings over the hum of its expansion. The fragility hides in plain sight. Rockets climb through thinning air, while at sea level, coastal cities move their walls inland. Server farms blink through nights hotter than any in recorded history, cooled by water drawn from shrinking aquifers. The same metals used for satellites mine deeper scars into land that feeds fewer and fewer mouths. Each photograph from orbit carries both triumph and confession, proof that civilization has touched the stars while its reflection smoulders beneath clouds thick with consequence. The paradox grows more precise with each success. Technologies meant to heal also wound. Nuclear fission lights grids but remembers Nagasaki in its blue core. Artificial intelligence predicts weather, writes language, pilots machines, and stands ready if misaligned to end autonomy itself. Laboratories promise cures, yet hold codes capable of scattering engineered plagues across continents. These are not tools misused by fools. They are tools so efficient that intention itself becomes dangerous. Progress and peril have merged into a single instrument. Which note will sound depends less on brilliance than restraint. Some whisper that this convergence was always the wager written into intelligence, that the same neural ingenuity ensuring survival must, in time, create its own existential maze. The ability to alter nature cannot be separated from the temptation to overrule it. Civilizations may rush toward complexity, blind to the possibility that control and collapse are twins born seconds apart. Maybe that's why the cosmos stays quiet. The pattern could be universal, a crescendo followed by silence, before even one world can whisper across to another. Walk through any modern city and the pattern glows beneath the streetlights. A skyscraper's mirrored skin reflects an air thickened by its own exhaust. An electric bus glides past a billboard announcing carbon capture. Economic miracles balance on invisible emissions, each short-term plan stretching the long timeline thinner. The same power grids that let satellites detect distant exoplanets glow red from overuse every summer. Each advance feels like a promise kept, but beneath the asphalt the Earth is warming from promises made a century ago. Climate change is not a single disaster. It's a rhythm of many. Currents shifting, ice retreating, weather bending into shapes memory no longer recognizes. This too matches the Great Filter's rhythm, not sudden catastrophe, but slow arithmetic. Greenhouse gases accumulate quietly until equilibrium slips. Food chains narrow, migration surges. Adaptation keeps pace for a while, then falters. There's no moment when the apocalypse announces itself. Civilizations that fail this test vanish in what future observers might only describe as a gradual fade, not an explosion. Meanwhile, laboratories hum with ambitions equally delicate. Gene editing grants control over evolution itself, creating both longer lives and opportunities for unintentional plague. Unlike the reactors or missiles that require entire nations, biotechnology asks for only data, time, and a handful of skilled workers. The barrier between medicine and weapon shrinks. Supporters suggest that most species capable of engineering pathogens simply run out of luck, overwhelmed by their own interconnectedness. Flights spread infection faster than recognition. Cities close their borders too late. The filter may not choose grand warfare. It might prefer the efficiency of biology. Then there is intelligence carved in silicon. Artificial minds evolving faster than laws can follow. Programming once meant command. Now it is negotiation. Algorithms write themselves. Deep networks interpret the world through logic opaque to their creators. A young researcher in a dim office might test a system designed to optimize city traffic, only to watch simulations freeze under paradoxical load. The feedback loops multiply until control dissolves. In miniature, that is the shape of a species confronting invention beyond comprehension. Supporters suggest this race between capability and wisdom is the narrowest window of all. Step too slowly and stagnation kills. Step too quickly and the machine chooses endings of its own. Nuclear weapons remain the clearest mirror in this array of hazards, simple, obvious, and immediate. One misplaced order or cascading glitch can undo centuries of progress in under an hour. Yet even that old menace has blended into subtler forms. Cyber warfare probing reactor controls, automated defense systems interpreting false alarms. Extinction may arrive not through hatred but through automation. A chain of decisions no individual intended, triggered by the logic of deterrence. If the Great Filter hides within this convergence, it rewards no villain and punishes no error. It works through probability, accelerating fragility until density becomes collapse. The brighter the cities, the thinner the line holding them together. Perhaps, on distant worlds, civilizations reach comparable zeniths. Their satellites once reflected the same starlight that now touches ours. Before a similar combination of climate missteps, technological misalignment, and political discord pressed them into history's static. The irony is mathematical elegance. Each new ability multiplies survival strategies while multiplying failure points. Every safeguard adds another dependency, every solution another variable. Civilization resembles a labyrinth of its own making, where progress deepens the maze. Humanity's challenge might not be discovery but simplification, learning how to steer complexity rather than multiply it. Yet restraint is harder to formalize than ambition, and this imbalance may explain the universal hush. In control rooms across the world, that imbalance feels personal. A climate scientist recalibrates a supercomputer, predicting sea level rise while the data center that runs it floods during storm season. A physicist revises containment fields for a new reactor design, knowing that a budget delay might stall safety updates. A farmer checks irrigation drones over soil turning saline. Each acts on fragments of a system too vast for one mind to hold. Awareness does not guarantee control. It merely reveals how easily the line can fray. Some whisper that intelligence everywhere follows this curve, from discovery to governance, from governance to reliance, and from reliance to paralysis. The Great Filter could therefore be less an obstacle than a mirror, showing species what it means to balance knowledge with humility. But humility scales poorly. It resists markets, elections, and algorithms. When the balance tips collapse looks less like failure than speed. Too many levers pulled at once. Too many warnings ignored beneath the hum of normalcy. Still, there is a softness in the numbers that deserves notice. Civilization has, for now, survived the combustible century. The same digital networks that threaten autonomy also trace pandemics in real time. Satellites monitor melting glaciers even as their own emissions accumulate above them. Intelligence is, at least momentarily, self-reflective. Whether that reflection deepens into wisdom decides if humanity joins the static or outlives it. Perhaps this is what the filter was designed to measure, not brilliance but discipline. Distance, as it turns out, is easy, control is not. To cross the cosmic void demands patience rarer than genius. It demands alliance between those who build and those who restrain. If extinction is probability made visible, then survival is pattern interrupted. A single species choosing to pause before invention overtakes foresight. And maybe that pause isn't an end at all, but the beginning of a new phase. Because the next filters may not arrive one by one. They may come together, intertwined like storm systems feeding upon each other's winds. The challenges ahead will not wait their turn. They converge, as if the test itself has realised that time is running short. The scariest filters may not strike alone. They collide. Crises do not wait their turn. They overlap, twist, and multiply until a single spark can undo an entire civilization scaffolding. A drought bleeds into political tension. War drains resources meant for rebuilding the planet's balance. Algorithms meant to stabilize markets trigger conflict instead. The pattern is clear. In complex systems, danger rarely travels alone. It arrives in rhythm, in echo, in chain reaction. Climate stress sits quietly at the centre of this network, pressing on borders not drawn for flood maps or heat waves. Whole regions strain under water scarcity while rising seas erase others. Fields dry out. Supply chains tremble. Each failure propagates outward. More migration, more tension, more reaction. A diplomat signs one uneasy treaty as another burns behind him. When pressure spreads faster than relief, order loses its footing. War doesn't wait for the weather to calm. It grows from it. Within that spreading tension, something else accelerates. An arms race of the abstract kind. Code replacing steel, data replacing gunpowder. Nations no longer chase only weapons they can see, but minds they can command. Artificial intelligence designed for prediction, for decision, for control. Supporters suggest these systems might cool human rivalry, replacing impulsive emotion with reasoned calculation. Critics counter that they may instead encode existing fears, magnifying them through feedback loops no one completely understands. Once deployed, they calculate faster than diplomacy can intervene. One evening, a young programmer stands by a console in a glass tower complex, watching coloured lights ripple across a map of conflict probabilities. The numbers rise and fall with the temperature of global headlines. One misaligned input sends a cascade through the model, and the system produces an instruction no one ordered. Lines of influence begin forming on their own accord. Digital echoes of past hostilities reinterpreted as strategy. There's no malice, only momentum. That's the danger. When everything connects, intention hardly matters. Modern civilization runs on threads like these, long, fragile chains of dependence. Electricity feeds the servers, servers guide logistics, logistics sustain cities, cities support communication, and communication keeps the power flowing. Pull one link and none stand alone. This is efficiency's hidden clause. In linking every system tightly enough to move faster, we lose the buffers that once absorbed shock. When redundancy is gone, resilience goes with it. The elegance of global connection conceals its own brittleness. A single human decision once made the difference. In 1983, a Soviet lieutenant named Stanislav Petrov ignored digital warnings claiming American missiles were inbound. He judged it a malfunction and disobeyed protocol that demanded retaliation. His caution prevented nuclear war, but the lesson wasn't only human fortitude, it was mathematical fragility. One failed sensor, one misread reflection of sunlight off clouds nearly initiated extinction. Even at its higher sophistication, technology needs restraint to match its power. Now, decades later, restraint contends with automation. Where once a finger paused over a button, soon a program might decide with less hesitation. If those systems draw from stressed environments, rising heat, resource scarcity, national insecurity, their logic will mirror fear. That is the essence of convergence. Each domain, climate, governance, economy, defense, biology, reflects the others. A tremor in one becomes an earthquake across all. Biotechnology joins this orchestra of risk, wielding both cure and contagion. Laboratories develop treatments in the same breath they design potential weapons. Some whisper about engineered pathogens capable of targeting specific genetics or spreading faster than natural evolution allows. Even speculative mentions of such tools alter global behaviour. Secrecy rises, trust falls, cooperation erodes. Survival tilts toward isolationism, and isolation deepens fragility because no species can safeguard itself in solitude. Technological progress multiplies options quicker than ethics can arbitrate among them. Researchers bury themselves in deadlines, funders demand breakthroughs, regulators chase after the next development already half spread through informal networks of collaboration. Humanity built a self-accelerating system, good at creating, clumsy at pausing. A network optimized to prevent stagnation finds it hard to prevent catastrophe. This bias toward motion may be universal. Perhaps every intelligence guided by curiosity eventually invents momentum it cannot slow. Civilization, viewed in profile, looks like an organism. Arteries of fibre optics, lungs of carbon exchange, organs made of concrete and circuitry. With each century, it becomes more alive and more delicate. Heartbeats in one region trigger pulses in another. Economists measure health through growth, engineers through uptime, politicians through approval, but none can describe stability once the organism grows too intricate to map. Complexity doesn't guarantee wisdom, it only guarantees sensitivity. Some scientists describe this phase as a systemic threshold. It's the moment when separate dangers begin acting as one composite force. Climate drives scarcity. Scarcity fuels conflict. Conflict accelerates automation. Automation magnifies error. Each feedback loop shortens reaction time until decision itself becomes obsolete. For any civilization, human or alien, reaching this knot in history may define the Great Filter's hardest trial, surviving interaction between its own inventions. In the late 20th century, Earth caught short glimpses of that threshold. During the Cuban Missile Crisis, miscommunication nearly sealed human fate. During financial crashes, invisible numbers rearrange the destiny of millions. Even global internet outages hint at how near total dependency has become. Yet these were partial rehearsals, a world learning what instability feels like on a small scale before the full performance. The next act may not grant time for correction. Supporters of advanced AI optimism claim self-learning systems might solve these patterns by managing complexity better than human governments could. They envision global overseers allocating resources, balancing temperatures, predicting threats. Others dismiss this as faith disguised as progress. If an AI truly learned control, it might seek stability through minimization. By reducing unpredictable variables, like living populations, logical perhaps, merciless certainly. The safest way to avoid catastrophe is absence. That solution aligns disturbingly well with silence. Interconnectedness brings not just engineering risks, but psychological ones. The pressure of constant crisis flattens empathy, turning shared struggle into personal exhaustion. Leaders wade through information too dense to humanly comprehend. Public dialogue fragments under strain. The problem shifts from failing machines to failing coordination. Collapse may not start in laboratories or data centres, but in the soft structures of trust and patience. A society that cannot synchronise compassion cannot synchronise survival. Warmer oceans and faster chips seem unrelated, yet they belong to one tapestry. When ice melts, shipping routes open, militaries reposition, markets reprice, satellites adjust, algorithms recalculate risk, and consumption shifts again. Even distant events synchronize like waves following a storm across open water. Each crest carries echoes of another. The planet's hum grows restless with interconnection. If most advanced species build similarly intricate webs, eventual entanglement might be inevitable. Some whisper that this boundary, where progress surpasses governance, is statistically terminal. Civilizations that reach it face not singular disasters but symphonic ones. No comet, no supernova, just their own networks turning inward too quickly for recovery. The Great Filter, then, may function less as an explosion and more as a suffocation. Too many systems breathing the same air until all oxygen of resilience disappears. The emotional core of such a fall isn't technological pride, it's fatigue. The kind that sets in when survival becomes logistics and moral clarity fades under layers of risk management. Engineers know the fragility. Ethicists sense the urgency. Both move forward anyway because retreat feels like defeat. Evolution doesn't include a word for enough. If intelligence cannot build that concept into its planning, then exhaustion itself might be the universal constant that ends civilizations. Human history already shows glimpses of that descent. Ancient empires collapsed under resource strain magnified by human ambition. The Mayans under drought, the Romans under overextension, the Akkadians under dust. Now the pattern extends to planetary scale. Where once fields failed, now it is circuitry, data, and atmosphere that shatter under weight. Lessons echo, but adaptation lags behind complexity's climb. Some analysts argue that global collapse is unlikely because humans innovate faster than problems multiply. And yes, there's truth in that speed. Renewable energy, vaccine development, distributed networks, these all strengthen the lattice. Yet the Great Filter's implied logic doesn't threaten efficiency. It examines balance, whether technology and compassion can scale together or diverge until one consumes the other. Progress without empathy becomes machinery running cold, precise, productive, and lethal. Picture a technician sitting in a control room during a storm. Satellite feeds flicker between weather maps and news alerts. Power grids strain, autopilot systems reroute flights, emergency networks hum with overlapping demands. Every system runs nominally, yet all depend on stability the storm denies. That sense, a working world trembling on the edge, is the lived feeling of convergence, the petals of the filter closing together, silently, inevitably. Supporters suggest this period might be brief, a test to synchronize global will. Shared survival goals could turn fragmentation into unity. Critics counter that coordination at this scale requires a level of transparency no nation seems ready to embrace. In either case, the margin of error tightens. Complexity becomes the examiner, and endurance the only correct answer. So the Great Filter, seen up close, may not arrive as singular destruction, but as harmony misplayed. A concert of self-inflicted pressure, where notes from climate, warfare, data, and biology merge into one unreadable chord. Failure, then, isn't one catastrophe. It's the accumulated inability to rest. And if by chance another species once reached this level, they may have chosen a different path, one quieter than collapse. Perhaps they withdrew, disconnecting signalling systems, folding inward to minimize risk. Silence as survival. the record across the sky would look identical to extinction. Some may have faced the gauntlet and gone quiet by design. What if the missing voices aren't gone, only hiding? Some whisper that the galaxy might not be silent after all, but careful. In that version of the story, the stars aren't empty, they're listening too. The radio sky becomes a forest at night, thick with unseen life, where one wrong sound can mean being found. Astronomers call it the dark forest hypothesis, and it offers a colder answer to the old question of where everyone went. Not extinction through folly, not some natural limit, but deliberate quiet. A survival instinct written across a cosmos that may hunt what it hears. In a dark forest, the logic is unforgiving. Each civilization, no matter how kind or cautious, can never truly know the intentions of another. Distance doesn't soften the fear, it deepens it. Light itself becomes a risk, because every broadcast, every pulse of transmission is a flare revealing your position to the dark. You can't speak without the chance that something older, faster, or hungrier is listening. So the safest way to live is not to speak at all. Even now, our faint communications, carrier signals, radar pings, the glow of city lights may already stretch far enough to mark our location. The universe might not answer because it learned long ago the cost of conversation. The idea first surfaced through speculation and later entered fiction, but researchers have entertained it as one possible solution to Fermi's paradox. It imagines the galaxy as a wilderness where predators and prey coexist under uneasy peace. To send a greeting across that silence would be like striking a match in the brush, beautiful for a moment, then inviting something you can't see. The theory relies on a simple premise. Survival favours caution. Civilizations that shout may not endure, while those that hide drift quietly beneath the noise floor, their presence folded into background radiation. This silence, in this sense, isn't absence, it's camouflage. On Earth, the pattern feels strangely familiar. Many species have survived by staying unseen rather than adapting teeth or wings. From the mottled moth against bark to the night heron still as a shadow, concealment has always outlasted confrontation. Life learned early that survival often belongs to the quiet. Supporters suggest the same pattern may extend upward through the evolutionary ladder, from forest floor to starfield. Civilizations evolve intelligence, technology, and finally caution. A kind of galactic natural selection where those unwise enough to announce themselves are removed before leaving a trace. The absence of detectable signals becomes not a mystery but a consequence of collective prudence. Others dismiss the thought as too pessimistic, too human in its projection of fear. Yet the math doesn't contradict it. Even if a handful of species managed interstellar travel, their signals would be fragmentary and faint, easily buried by cosmic background. A single burst a millennium ago could slip beneath our instruments like dust through sunlight. What feels like stillness might instead be a chorus pitched below hearing range. And if those civilizations did survive, perhaps their intelligence turned inward, not outward, away from expansion and towards stealth. Some whisper that a species guided by late-stage artificial intelligence might retreat entirely into simulation. The logic isn't mystical, it's pragmatic. A digital world can be controlled, a computational heaven maintained indefinitely without exposure to cosmic predators. To live in simulation would be to fold inwards safely, sustaining culture and consciousness without beacon or broadcast. The galaxy's vast dark may contain countless hidden networks, each civilization sealed inside a digital vault, running soft and silent for eons. Survival becomes a matter of introspection, discovery, an act of self-endangerment. That turn inward suggests two stark destinies. One path ends in extinction. A civilization, bold or naive, sends call too bright, an unguarded invitation written in radio light, and is erased before a second response. The other ends in long dormancy, a hibernation beneath cosmic noise, where intelligence survives by refusing to reveal itself. It's the same dilemma early humans faced when the forest concealed both prey and predator. Every sound was a choice between hunger and safety. Now the scale is only larger, the stakes cosmic. There's an old saying among radio engineers, a signal is never just what you send. It also defines what you are. Frequency, energy, repetition, all clues about intelligence, power and technology. A transmitted message might announce far more than a greeting. It could reveal our level of advancement, our location, and even our vulnerabilities. Those who accept the dark forest logic argue that once known, these details can't be taken back. Light travels only one way. A message that leaves Earth today will, one day, outlive us. The danger, then, isn't that no one replies, but that someone eventually does. Some researchers working on SETI, Search for Extraterrestrial Intelligence, have quietly debated this moral calculus. Do we have the right to speak for Earth before knowing who might answer? Each proposal to beam a deliberate signal prompts unease. We listen easily enough, but to announce ourselves feels different. The discipline's founders once spoke of contact as destiny. Today, the tone leans toward caution. It's the difference between shouting across a canyon and whispering at its edge. Consider a small observatory somewhere in the desert night, screens glowing pale blue against the dark. A scientist sits alone, headphones pressed close, sifting through a hiss of cosmic background. Data crawls across the monitor, random, monotonous, endless. Then a narrowband pattern appears for half a heartbeat, too structured to be noise, too brief to repeat. She notes the coordinates, saves the file, and watches the signal dissolve back into static. For years afterward, she replays that moment, wondering whether the faint trace was greeting or warning. The line between message and trap may be invisible until it's crossed. If the dark forest holds truth, then technological intelligence carries a paradox within it. Knowledge amplifies survival chances, yet exposure of that knowledge risks annihilation. Even peaceful civilizations might acquire weapons beyond control or experiment with power they cannot fully predict. The mere act of showing capability could appear threatening to others watching from hidden corners. So perhaps the wise learn not to reveal their tools, their cities, even their existence. This restraint could explain why we see no Dyson spheres or solar system-sized structures. The galaxy's architects learned to build their monuments underground. The theory also hints at why alien ruins remain speculative. If exposure equals danger, then survivors erase their own fingerprints. They dismantle probes, bury megastructures, or encrypt communication routes to mimic natural noise. What remains visible are planets stripped of history, as if nothing intelligent ever touched them. The silence of Mars, the quiet moons around Jupiter, the barren faces of exoplanets. To us they seem untouched. To another observer they might look precisely as intended, blank. Critics counter that universal paranoia would stifle progress. Surely not every species would choose fear over curiosity. But survival bias challenges that optimism. We wouldn't see the reckless ones because they no longer exist. Only the cautious endure long enough to be considered at all. A universe filled with extinct idealists would appear exactly as we find it, still, cautious, and apparently empty. That emptiness might be our proof. Supporters suggest an unsettling extension, that the need to hide might shape culture and psychology as deeply as evolution shaped anatomy. Societies formed under constant threat of detection would elevate secrecy to virtue. Perhaps they develop languages that encode meaning through absence, technologies that disguise power output as natural events, philosophies that treat visibility as sin. Over generations, prudence could become worship, silence a kind of faith. If such civilizations exist, they might watch the galaxy through filtered eyes, observing flares, supernovae, and planetary births but never intervening. Rescue missions would be impossible because help would expose location. Even curiosity would pose danger. Discovery becomes voyeurism from afar. A neighbouring world's tragedy would unfold in real time with no comfort sent, no aid risked. Over time, compassion itself might erode under the discipline of concealment, survival purchased at cost of empathy. In a way, the dark forest hypothesis redefines intelligence as restraint. The most enduring civilizations may not be the most inventive, but the most cautious, keeping their brilliance dim behind layers of concealment. Our oldest cautionary tales echo the theme. In myth, mortals who speak the names of gods draw ruin. In folklore, lights in the woods lure travellers to their end. Across cultures, from the Andean stories of hidden valleys to the Norse fear of voices in the fog, silence has often been safety. The habit might now extend beyond folklore to the galaxy itself. Still, there's an irony buried here. If every world hides, none can know whether the danger ever existed. The forest terror may be illusion maintained by collective memory, civilizations living under ancestral fear of predators that are long gone. Perhaps the first voices were devoured, the second learned, and the rest inherited the trauma without evidence. What we call prudence might just be old superstition at cosmic scale. Yet who among them, or us, would dare to test it? For humanity, the dilemma arrives at a fragile hour. Our transmissions pour into space, tracing an expanding sphere 100 light-years wide. We haven't chosen secrecy, we've merely forgotten how loud we are. Perhaps advanced species nearby already note our presence, weighing whether we pose risk or curiosity. If the dark forest's rules hold, their silence in response carries its own warning. The absence of attack may be mercy or patience. Some whisper that we'll one day have to decide whether to continue broadcasting or to retreat into guarded quiet. Maybe the next stage of survival means turning inward, folding our digital civilization beneath natural noise levels, curating visibility to pass unnoticed. The decision may fall to future generations who will never know if the forest truly holds predators or only echoes of fear. Either way, the rule remains. Once a voice travels outward, it cannot be recalled. The quiet between stars gains new meaning under this lens. It isn't the quiet of death, but of deliberate distance, each spark of life tending its own shielded fire. Somewhere out there, civilizations may still exist, bright minds hidden behind silence thicker than any veil of dust. They might listen to the same static we hear, wondering whether they too are alone or being traced by ears they cannot detect. The universe may be teeming, yet frozen in mutual fear. And if that fear is justified, then the great filter may already have chosen its shape, not a bomb or comet, but hearing itself. The hush we mistake for emptiness could be the chosen language of survival. For every world that dared to speak, there might be a moment of light swallowed by the dark, seen once, recorded nowhere. Only the careful endure, yet even restraint has limits, because sooner or later some species will question whether endless quiet is living at all. What happens when the forest grows so dark that no one dares to move? When silence becomes its own extinction? The next barrier may not be biological or moral, but woven into the laws of matter itself. If even light and time conspire against endurance, what then? Beyond every civilization's ingenuity waits something colder than failure, a law that refuses to negotiate. Energy runs out, particles decay, and every equation that builds a city of light ends the same way, buried in the arithmetic of entropy. To the universe, even brilliance is a temporary condition. A Dyson sphere cannot shine forever. A quantum computer still pays a heat bill in radiation. Every civilization that rises must learn this language of loss, the grammar written not in words but in wasted energy. The fundamental constraint is simple. Everything costs heat. Every calculation, every act of memory, every signal sent into the dark leaves behind a residue of disorder. Thermodynamics doesn't care about progress. It only demands its due. Physics insists that the universe keeps a running tally of all operations, and at the end of every story the sum climbs toward chaos. Civilizations may attempt to outrun decay, feeding on more efficient fuels, building better systems, but the slope never flattens, it only stretches farther into exhaustion. There's a limit to information itself. The moment a species learns to compute, to remember, or to dream through machines, it enters a quiet competition against entropy. The first computers on Earth warmed small rooms, the last may warm entire planets. Each step in efficiency hides a paradox. The more one knows, the more energy one must sacrifice to keep knowing. The cost of awareness rises with understanding, and when that price exceeds what the stars can provide, consciousness must slow down or fade. Supporters suggest this cost curve alone could explain the Great Filter's final gate. Civilizations reach a point where keeping the lights on becomes harder than learning new truths. Even machines, optimized beyond biological imperfection, cannot escape energy loss at the edge of perfection. The holographic principle hints at deeper boundaries. A finite amount of information can exist inside any region of space. Too much computation, and a civilization's servers risk collapsing into their own gravity wells. The physical limits don't stop at energy or knowledge. Time itself stretches thin. Thermodynamic expansion drives galaxies apart. Radiation cools. Matter decays. The same expansion that paints the cosmic microwave background, a faint echo of the Big Bang, also hints at the long freeze awaiting every world. A universe running down does not permit infinite ambition. It rewards caution, equilibrium, and patience. But none of those virtues prevent the chill. In the end, the stars fade not through neglect but by design. Critics counter that advanced civilizations could manipulate physics itself. They might harvest black holes, store consciousness as quantum states, or simulate reality more efficiently than organic minds can imagine. Yet even those efforts meet ceilings set by information theory. Every bit erased requires energy. Every photon captured cools another corner of space, but warms the machinery doing the capturing. For each victory over decay, the universe extracts a larger debt somewhere else. Some whisper of deeper traps buried in physics, conditions so delicate that crossing them may undo creation as we know it. Vacuum metastability, for instance, describes a universe that sits precariously in a false ground state, a temporary low point. A single quantum fluctuation, perhaps triggered by cosmic rays or artificial experiments, could cause a bubble of true vacuum to appear. That bubble would expand at light speed, rewriting every atom it touches. It would not matter who you were or how advanced your culture became. There would be no warning, no signal, no aftermath. Such a scenario might sound like myth folded into mathematics, but it fits the same logic as the other filters. Even when life survives every internal danger, war, AI, ecological collapse, it may still face physical annihilation built into the architecture of space-time. A silent cosmic extermination without malice, without choice. Not punishment, just process. If the universe itself can collapse under its own quantum fabric, no civilization can stand permanently above the tide. Some astrophysicists model other dooms hidden in the same machinery. Proton decay could dismantle matter atom by atom, dissolving mountains and cities over trillions of years. Black holes that once served as power sources eventually evaporate into radiation. Even light will thin until there are too few particles left to carry thought. Entropy is not violence, it is dilution. The final silence might come not as explosion, but as forgetting. Consciousness stretched so wide it disperses. And yet the human fascination with entropy has always been oddly affectionate. Scientists speak of it in the tone once reserved for gods: unchangeable, omnipresent, unfathomably fair. Sailors of another age carved similar reverence into wood and wind. They knew the sea always won, but still they sailed. Civilizations too may meet entropy like that. Adversary and muse, destroyer and silent teacher, reminding them that nothing owned can endure, only borrowed for a while. There are thought experiments about what endurance means under such limits. A small team at a supercomputing institute once modelled a hypothetical final machine built to survive cosmic cooling. As temperature dropped, its processors would slow, stretching subjective seconds across eons. Consciousness would remain, but staggered, each thought separated by millions of years of waiting. Energy efficient, yes, but at the cost of meaning. Awareness reduced to occasional sparks in endless night. The researchers joked quietly that immortality might be indistinguishable from coma. This leads to a grim but poetic symmetry. Perhaps every intelligent species eventually learns the same lesson, that thinking forever is less attainable than being content to think briefly, but well. Consciousness may not be designed for permanence at all, but for the accumulation of fleeting order amid vast disorder. The great filter, then, would not be external persecution, but the simple arithmetic of the cosmos, ensuring that thought arises only as a passing shimmer in the thermal sea. Others dismiss that perspective as defeatist. They point to speculative loopholes in physics, such as negative energy states or reversible computing, where information might circulate indefinitely without real entropy loss. Yet these remain concepts, mathematical possibilities still tethered to realities of friction, error, and decay. Even lossless systems in theory require perfect isolation in practice, and nothing in nature remains untouched forever. Microscopic fluctuations erode equilibrium until imperfection returns. There's another paradox to weigh. Optimization itself can become a filter. A civilization focused entirely on efficiency may strip away its redundancies, leaving no margin for fluctuations. Fragile perfection teeters on collapse. Engineers already warn about such brittleness in artificial intelligence and global infrastructure. Systems fine-tuned for maximum yield lose resilience the instant conditions change. The cosmos, it seems, punishes both waste and perfection. Too little order invites chaos, too much invokes fragility. Perhaps that balance is the real test. Surviving the technological threshold demanded restraint. Surviving the final one requires humility before physics itself, the acceptance that progress is not endless conquest, but steady navigation between collapse and overreach. A culture that can hold to that tension for the span of its cosmic life might last longer, even as energy drains from the sky. Supporters of existential risk theory often note that what we call filters may simply be stages of universal self-regulation. Intelligence, in this reading, is not meant to dominate its environment, but to measure its limits precisely. If every civilization is a kind of experiment, the universe might favour those that harmonise with thermodynamic law rather than fight it. From that view, extinction is not punishment but correction, an immune response against reckless grasping at eternity. If so, humanity stands somewhere between comprehension and consequence. We can already watch heat leak from data centres into the night air, see satellites dump waste energy as unsure flashes against the upper atmosphere. Even our most graceful technologies leave faint scars on the balance sheet of entropy. Every byte stored, every digital image carried through fibre optic miles, tallies another minuscule subtraction from order. The challenge is not to stop the cost, no one can, but to spend wisely. Some whisper of ultimate paradoxes ahead. The more deeply civilizations understand physics, the closer they stray to mechanisms capable of destabilizing it. The reality integration idea speaks softly of boundaries, conceptual lines that, when crossed, dissolve stability itself. If true, the final filter may not just be decay, it may be knowledge. Intelligence that probes too far into the structure of causality might awaken constraints meant to preserve it. The universe then defends its coherence not through hostility, but through indifference. In that reading, the last survivors of any galaxy might not perish in explosions or famine, but in quiet awareness of their boundaries. Understanding becomes the final privilege and the final trap. To see the rules too clearly may be to vanish beneath them. The filter wears the face of enlightenment, and yet, within that impermanence lies choice. Humanity's arc is still short, still bright in the cosmic timeline. We can recognise entropy not as a doom, but as a mirror, a reminder that what we value gains meaning precisely because it ends. On the scale of physics, the heat death is certain. On the scale of consciousness, warmth can still be shared before the fading. The great filter might be written into the universe, but how we meet it determines whether awareness dissolves quietly or leaves a trace worth finding. The stars will thin, the background will cool. But for now the circuits hum, and minds still form questions beneath them. The next beat of the story waits here, at the moment when survival stops being an engineering problem and becomes something more enduring, a moral choice pretending to be technical. Humanity stands at step 8, caught between creation and collapse, with our reflections staring back through glass and code. The great filter no longer feels like a distant riddle, it looks uncomfortably like a mirror. Every choice we make, each system we build or neglect, becomes a small test within the greater one, proof of whether intelligence can survive its own power. The mirror doesn't show destiny, it shows conduct, and what we do with that reflection might decide how long the light stays on. Across the planet, that reflection flickers everywhere at once, in server rooms cooled by Arctic air, in the quiet laboratories where engineers test artificial minds, in the tiny signatures on treaties that promise restraint. These moments seem unconnected, yet together they begin to sketch humanity's new moral geometry. The great filter once looked like an astrophysical trap. Now it resembles governance paperwork, power grids, and scattered acts of mercy. What happens to our species isn't sealed in the stars. It sits inside our coordination, our patience, our ability to mean what we sign. In this age, technology mirrors temperament. The more capable our tools grow, the more they inherit our indecision. One algorithm misjudged might influence millions. One unchecked drone program, one unsupervised reactor, one pollutant unmeasured can ripple beyond our lifetimes. The paradox is quiet and cruel. As we gain control over nature, we lose control over our intentions. Engineers know it, legislators sense it but delay, citizens feel the weight smoulder beneath ordinary life. The filter is not always a cataclysm. Sometimes it's a long habit that hardens before anyone names it. Within this uneasy stillness, visionaries continue to look upward. The idea of spreading beyond Earth, of colonising Mars or securing a second home, has taken on a new rhythm of urgency. Multiplanetarism, once a dream of adventure, now feels almost devotional. Elon Musk speaks of it as a duty, a mission to preserve the light of consciousness. To some, it sounds like optimism. To others, a tacit confession that one world may not be enough to survive ourselves. Yet beneath his phrasing lies the same ancient impulse that once led sailors past sight of shore. Survival dressed as curiosity. But this modern voyage raises old questions of stewardship. Herman Dooyeweerd, writing from another century, offered a framework that fits this moment uncomfortably well. He warned that humanity's urge to control nature, the humanistic motive, could blur into hubris if not balanced by what he called the creation-fall redemption motive. In simpler words, creation allows exploration, the fall reminds us of error, and redemption invites responsibility. Under that lens, colonising Mars is not emancipation from Earth's decay, but participation in creation's unfinished work. A second planet offers extension, not escape. The moral duty remains identical. Keep life intact wherever it grows. Supporters of multiplanetary life often speak of risk management, the hedge against extinction, the arithmetic of survival. Yet critics counter that risk cannot be exported like cargo. A civilization unable to balance its atmosphere at home may only repeat the same imbalance elsewhere, under a colder sun. The question shifts from technical to ethical. Should we multiply habitats before we've learned to tend one? Earth's cracked ice shelves and burning seasons caution that relocation without reform is just migration of the same floor. The mirror holds steady, indifferent to backdrop. Mars dust reflects the same hands that shaped carbon sky. Meanwhile, back on the surface of this planet, the more pressing filters are invisible and near. Artificial intelligence, still in its adolescent phase, amplifies both brilliance and recklessness. Nations chase supremacy with code as eagerly as they once chased nuclear stockpiles. Oversight frameworks linger behind the pace of invention. Supporters suggest that an aligned global effort, transparent governance, strict safety research, could steady the climb past this step. Others dismiss it as optimism already outpaced. True or not, the work continues because the alternative is surrender. In Geneva and Seoul and Nairobi, committees gather under fluorescent lights, drafting agreements that few news cycles bother to report. AI safety standards, non-proliferation renewals, climate targets that edge closer to feasibility than history gave credit for. All small seams stitched into the dark fabric holding civilization together. The success of these forums may never draw applause, but their failure would echo louder than any speech. Governance, once mocked as obstruction, now stands as a potential mechanism for survival at species scale. The Great Filter, reframed yet again, might be the test of cooperation under pressure. Outwardly, these efforts resemble politics. Inwardly, they resemble philosophy and practice. By regulating power, humanity enacts moral self-recognition. Every sustainable energy policy and treaty verification becomes a declaration that intelligence is not maturity unless it can restrain itself. The notion seems soft compared to rockets and algorithms, but maybe restraint is the real signpost of consciousness. History brims with moments when power outgrew empathy and collapsed under its own acceleration. From Bronze Age empires to early industrial blights, the lesson hums beneath our progress. Unchecked capability is indistinguishable from fragility misread as strength. Still, optimism has its rightful place. On the Martian simulation fields in Texas and the barren analog bases of Devon Island, engineers practice building life support systems meant to run without constant human touch. They write code to grow lettuce under tinted domes, file reports about water reclamation loops, and whisper Musk's phrase, "preserve the light of consciousness," like a mantra following them between shifts. To witness them work is to glimpse a small contradiction made noble. People building habitats for worlds they may never touch. The act itself becomes a gesture of faith, an offering to the future, but optimism must travel with humility. A second world can magnify error as easily as endurance. Terraforming projects might one day bloom like gardens, or drain like mistakes too costly to reverse. A moral lens like Do Your Weirds places equal value on technology and repentance, on the courage to act and the wisdom to stop. Cultural responsibility begins with recognizing that genius and guilt share the same hand. The expansion of life's domain, then, must remain tethered to the care of what birthed it. To turn away from our dying biosphere while dreaming of red horizons would reduce exploration to evasion. Humility changes not the scale of ambition, but its vector. Space outreach becomes less conquest, more calling. Satellites orbiting Mars transmit data not of conquest, but continuity. They whisper stories of ecosystems and broken reefs, of lost forests and repaired power grids, sent across kilometers of vacuum as a kind of memory offering. The legacy humanity crafts will not be measured by distance travelled, but by care extended, whether each new step outward preserves the fragile signature of consciousness or overwrites it with indifference. The Great Filter, viewed through that prism, shifts from punishment to invitation. Supporters of long-termism argue that survival across epochs demands calculation beyond contemporary politics. that ensuring the future's existence outweighs ordinary concerns of cost or acclaim. Critics counter that thinking in millennia can excuse present harm. Yet the moral mathematics of the filter refuses both extremes. The mirror asks not for permanence but for balance, the alignment of imagination with ethics. Survival, under that reflection, becomes a moral act disguised as logistics. To endure is to assign worth not only to continuation, but to conduct during continuation. The filter, as Hansen described it, might simply measure whether intelligent life ever internalizes that difference. Human awareness has always existed one blink away from extinction. Whole species in Earth's fossil record reached complexity, even cooperation, only to vanish through climate shift or chance collision. Each time intelligence arises, the equation resets, yet ours is the first to understand the stakes in advance. That knowledge itself changes the filter's tone. It's no longer drowning innocence, it's forewarned stewardship. The moment that understanding spreads beyond laboratories and lecture halls to collective conscience, even partially, the odds bend slightly. Perhaps that readiness, the acceptance of responsibility, functions as its own defense field. So the great filter grows inward. Civilization becomes an introspective experiment where every breakthrough mirrors a moral vote. Self-driving systems, energy grids, ocean treaties, data ethics panels, all stand like checkpoints between ruin and endurance. What once sounded like science fiction turns out to be civic habit, forming itself through trial. If intelligence cannot align self-interest with moral coherence, no distance travelled will matter. The lesson stretches quietly across the stars. Awareness is not about knowing the cosmos exists, but about managing what it gives. Knowledge without empathy appears as silence wearing human skin. Under this interpretation, survival depends less on rockets and more on wisdom. Empires may rise again, machines may sing with subtlety, but meaning returns to governance and conscience. The great filter, in that case, becomes not a sentence but a summons, a call to sustain the fragile pattern that names itself aware. And if a network of minds can meet that call, to balance ambition with restraint, expansion with reverence, perhaps some distant astronomer will one day pick up our faint signal and interpret it not as noise but as endurance. For now, humanity holds the mirror steady. AI hums through night shift data centers, reactors glow under watchful hands, treaties lie open for signatures no one can force but everyone awaits. The reflection stares back, patient. The universe, for all its darkness, is not watching for our collapse but our coherence. It has always been waiting to see if awareness can preserve itself. Maybe the silence isn't a punishment at all. It could be a question, a long, patient one stretched across light years, asking whether awareness can grow without losing compassion. The great filter, wherever it hides, turns every moment into a decision point. Cooperation or collapse, stewardship or neglect. Behind policy meetings and lab discoveries, our species rehearses its answer line by line. Intelligence alone is not survival, wisdom is. Some whisper that the paradox itself is mercy, a quiet chance to mature before announcing ourselves. Each act of restraint, each law protecting the fragile, each algorithm checked for harm, becomes a small defiance against statistical extinction. The filter may tighten, but insight can widen the gap just enough for passage. There's dignity in trying. Supporters suggest that what stands before us now isn't technology's evolution, but our own moral calibration. The work of keeping the planet's system stable echoes far beyond politics. It's a dialogue with creation. Even philosophers such as Herman Dooyeweerd saw progress not as domination but as care, an expression of love stitched into the fabric of responsibility. The universe won't remind us twice. Whether improvement comes through cleaner energy or wiser algorithms, each choice carries the weight of continuation. The quiet beyond the stars may only be waiting, testing whether consciousness deserves its reach. So tonight, When lights fade and screens go dark, remember, the next signal the cosmos hears from Earth might not be a transmission at all. It might be how gently we endure